Okay, with a hyperbola, it does the exact opposite of what the ellipse just did. So in ellipse, we had two parabolas facing each other. With a hyperbola, now we have two parabolas facing opposite directions. Okay, so we can have parabolas going this way. We can also have them going up and going down. When you get to pre-calc, they will start to go diagonals. Okay? So, on a hyperbola, it's the set of all points in a plane such that the absolute value of the difference of the distances from two foci, again, those fixed points, is constant. So now instead of adding those two lengths together, they say that the difference of the absolute value of the difference of them. So that would be subtracting them. The same thing that we did with ellipses, we're going to do with hyperbolas. So we're going to find the center, we're just going to graph them. Okay, so we're not going to worry about finding all the foci and that sort of thing. So the standard form equation of a hyperbola is this guy right here. Again, that's on your formula sheet as well. Let's look at that compared to an ellipse. Again, it's on the back side of your formula sheet. But what do you notice compared to an ellipse? So this guy right here is the hyperbola. This guy right here is the ellipse. What do you notice? I think I heard it. There's a subtraction sign. Yeah, this guy right here is a subtraction sign. That's the only difference. Okay? The other thing I want you to notice is that when we look at hyperbolas, I told you it didn't matter. We could add x and y. There's a big difference between subtracting y from x and x from y. Okay? So, the center is still at h comma k, but if the x squared term is first, then this hyperbola is going to open to the right and to the left. So if it's x squared minus y squared, he's a sideways one. If it's y squared minus x squared, so the y squared term is first, then he's going to open up or down. And I know it sounds cheesy, but the way I remember this is the YMCA song. Okay? The YMCA song starts out with your Y, right? You're straight up and down. If your Y is first, he's going to open up and down like your Y. Like I said, it sounds cheesy, but that's how I remember it. Okay. Every hyperbola still has two axes of symmetry. I'm not going to make you memorize what they are or anything like that. But I just want you to know that it still has two. So when we take a hyperbola, we can fold it this way, and my two parabola halves would line up on top of each other. Okay? One parabola on top of the other one. I can also fold it this way, and half of the parabola would fold up on top of the other half of the parabola for each one. Okay? So there's a transverse axis, and the endpoints are the vertices. It has a length of 2a. And then the conjugate axis is perpendicular to that. And it goes through the center, and it has a length of 2b. Again, I'm not going to make you find all these. But let's just fill in our notes because we've got them there. So use the equation c equals a squared, c squared equals a squared plus b squared, where c is the distance from the center to a focus, and a is the distance from the center to a vertex. Okay, again, we're just doing the center, and we're going to graph it. So find the set coordinates of the vertices, the foci, the slopes of the asymptotes. Nope. We're just going to find the center and graph him. Okay, let me throw a few things in here to this guy. X squared minus y squared equals 1. We've got a minus, so we know he's a hyperbola. This guy equals 1, so let's just throw in some zeros and some ones, a denominator, if you will. Okay, so just like my ellipse, where's my center? It's 0, 0. Just like when we were graphing ellipses, we're going to use those denominators. But instead of connecting them in an oval shape, I'll show you what we're going to do. So in my x direction, I'm going to go the square root of 1. Okay, so I'm going to go 1 to the left, 1 to the right. Okay, in the y direction, same thing. I'm going to go the square root of 1. So I'm going to go 1 up, 1 down. So he sort of has the look like he's going to be a circle. And we did the same method as we did for finding ellipse. But instead, we're now going to use this guy and draw in the dimensions of a box. Okay, so my box is 1 to the left from my center, 1 to the right of my center, 1 up and 1 down. Okay? All right, now, from corner of my box to the other corner of my box, I'm going to draw on a diagonal and I'm going to extend it in each direction. It goes through the corners of your boxes like that. Now we just have to decide which ways this guy is going to open. Okay, I have my x squared term first. I can also look at my formula sheet. My x squared term is first, so this guy's going to open to the left and to the right. These dotted lines that we just drew through our box are our asymptotes. Okay, they get closer and closer and closer to it, but they don't touch it. So what we do is we start at this point on our box, not at the center. Don't use the center, but we go to the edge of our box and we follow that shape. I'm going to do it in a different color. I'm going to follow that shape of those dotted lines. Again, it doesn't cross those asymptotes. It just gets closer and closer and closer to it. It tells it how far, how skinny to go, how tall to go, that sort of thing. So it's very similar to when we do it for an ellipse. Questions? Okay, let's try another one. Okay, let's just investigate this guy before we do anything. Notice that this guy is the y squared term first. So since the y squared term is first, that tells us, I'm going to think my YMCA song, that tells us this guy opens up and down. Also be careful, because when I list my center, I want the x coordinate first. If you look at your formula sheet, notice that it's always h and k. Well, h is now with x and k is always with y. So be careful when you list your center from this guy, because now my center, my h comes from here. So it would be -2, +4. Okay. -2. 1, 2, +4. 1, 2, 3, 4. This part also gets a little bit trickier because I have to look at the denominator for the x. So to figure out how to draw my box in the x direction, I have to look at the denominator under the x. So the denominator under the x is 9. I'm going to take the square root of 9. So I'm going to go 3 left, 3 right. Okay, in the y direction, I have to look for the denominator under the y variable. He's 16, so the square root of 16 is 4, so I'm going to go 4 up, 4 down. Draw in your box. Okay, from one corner of the box through the center to the other corner of the box, I'm going to extend and draw in my asymptotes. Okay, we know this guy opens up and down. This top point right here that we used to draw our box is now my vertice for my parabola. So I'm going to start there and draw my parabola and follow the shape of my asymptotes. Questions on hyperbolas? We've got one more to do, but I want to see if you guys have any questions about that before we do the last one.
How did you know that this is one of those
So on number 1, Jillian, the x term was first. So we did x minus y. And then in number 2, it was y minus x. So think about the difference between 1 minus 2 and 2 minus 1, right? Those two are two different ones. So if x is first, then this guy's going to open to the left and to the right. If it's the y term first, then he's going to open up and down. Okay, are we ready for number 3? I'm almost done. Okay, number 3. This one, same thing. We're not going to do the vertices and the foci and the slopes of the asymptotes. We're just going to find the center and then graph it. But this guy's not in the right form. So guess what we get to do? It's your most favorite thing. I told you we're going to do it 1,000,000 times. We're still doing it 1,000,000 times. We're halfway to 1,000,000, I guess. We also have to be careful because I have a negative right here. So what I'm going to do is I'm going to put a 1 there so that we remember that we want a minus sign out front. Okay, so let's complete this square. Just be careful when we do this. Remember, I put a -1 there so we can see it. So technically, he has a coefficient. So technically, we're going to have to divide this guy by -1 and the other y by a -1. All right, so here we go. I'm going to rearrange things. Add in my boxes. I'm going to pull that -1 out front because we have to have a minus between these guys. So now I have y squared minus 10y plus my triangle equals 17 plus my box minus 1 times my triangle. The trickiest part with hyperbolas is forgetting that that's a negative right there. All right, so my b here is 6 divided by 2 is 3, square it, 9. (10) divided by 2 is 5. Square it, it's 25. Ooh, that's really hard to see, sorry. All right, I'm forcing it to factor with the exact same 2 factors. So x plus 3 squared minus y minus 5 squared. If you want the 1 there still, just be careful that became a minus. 17 plus 9 is 26, minus 1 times 25 is just 1. So remember, if we got anything other than 1 there, we would divide it. But I'm going to go ahead and give us some denominators. Okay, which way does this guy open? Left and right, thank you. Where's my center? Thank you. All right, so negative 3, 1, 2, 3, 1, 2, 3, 4, 5. Take the denominator of your x. He's 1, so I'm going to go the square root of 1, which is 1 to the left, 1 to the right. Y, square root of 1, which is 1. 1 up, 1 down. Draw in a box. Sorry, he's a tiny box. Asymptotes through the corners, through the center. He's going to open to the left and to the right. We're going to skip 4 and 5. I'm not going to make you write an equation of a hyperbola going backwards. Questions on hyperbolas before we talk about your homework? Yeah, so it'll follow the same. It looks like two parabolas that go in the opposite direction. If you make them more like a V shape, Jillian, that's okay. Like, I'm not going to grade you how curvy they are or anything like that. So if you just start at the vertex, at that edge of that box, and follow the asymptotes, I'm happy. They just don't do, they're not like this, though. Does that make sense? So follow the shape of your asymptote. Okay, so let's look at your homework. Remember, look at number 1 there. This guy's in the right form. If you want to see it, throw those zeros in with him. So the thing you're going to do on this is you're going to tell me the direction of opening. That will be left, right, or up, down. And tell me the center. You don't have to do those. And then graph it. Okay, direction of opening and center for number 2. Don't worry about those. Graph it. Number 3, just like ellipses, you're going to divide this guy by 4. Direction he opens, center, graph it. Those first three right there are all centered at the origin. Okay. Number 4. This one's a little bit different, but let me show you. We need to move that y squared to the other side. Or sorry, x squared. And then you're going to divide everybody by 12. Throw in your zeros, simplify that. Again, direction he opens, center, graph it. Number 5. Same thing, he's in a nice pretty form. Direction he opens, this one be careful, the y is first. So your center is still h, comma, k. Number 6. You haven't had to complete the square yet. Center, which way he opens, graph him. There are only 2 where you have to complete the square. So, number 7, have to complete the square. Those numbers are big, but I made them big so that it works out nice and pretty. So this guy graphs really nice, okay, even though those numbers are big. Number 8, complete, oh yeah. Direction he opens, center, graph him. Number 8, not as big. In fact, you only have to complete the square with the x's because there's no plain y term. Direction he opens, center, and graph him. Okay?